Hello, and as always, welcome back to the TeamCity Kotlin DSL series. In this episode, we're going to refactor our build pipeline from last episode to get rid of the code duplication and just to make the code a bit more compact. Let's give it a try. So just to have a quick recap, in our settings KTS file, we have 4 build types: build, fast test, slow test, and package. And what we essentially did is we took the build type and just copy and pasted it 4 times into our settings KTS file. The build types, however, they look pretty much the same. So they have a name, they have a VCS root, and they have one Maven step. And the Maven step, the goals and the runner arguments differ slightly, but all in all these 4 different build types are pretty much exactly the same. So you could come up with the idea of saying, well, instead of having all these singleton objects, let's create a class, a Maven class. And let's extend from build type, like so. And then cut and paste whatever was in the build type into the Maven class. Now, the name is a variable, and also the goals and the runner args, as just mentioned, can slightly differ. So it makes sense to have a couple of constructor arguments, one for the name, one for the goals, and one for the runner arguments. And you can actually make the runner arguments optional by just giving them a default null value. Right. And then what you need to do is you set the name, you set the goals, like so, and also finally the runner arguments. Right, so now you have your Maven class, which means you can go back up to your project definition and simply create a new Maven object and say, well, the first build type simply runs Maven clean compile. That's it. You don't need any runner arguments. Which means you can now get rid of your build object. Right? So this works. You have your Maven object up here, but you would actually need a reference to that Maven object down here as well to specify the dependencies. And I don't want to extract a variable right now because there's an even better way I'm going to show you in a bit. So for now, let's leave in that compile error and just continue replacing these build types up here. Because if you think about it, the next build type you can replace is the package build type. You're just going to go clean package. And you'll need the skip test flag, which means you can go about deleting your package object now. Just one tiny note, the package object also has a trigger, a VCS trigger, and we have to think about that in a second. But for now, let's simply delete the package object. Now the only 2 things left are the tests, and for that, again, you might just want to start out with the fast tests. You're going to call Maven clean test, and now the runner arguments, I'm actually going to scroll down and cut and paste them up here, like so. Right. And then we can actually duplicate that line real quick. So we can go about writing the slow tests, and in here, the only thing that differs is the package, so .integration.test. And that's it. Which now means you can go and delete fast test. You can also delete your slow test object. Now, the only thing that's left is you have your project definition and your Maven class. That looks a lot better now, so it's in line. But you still have those 4 lines to register the build types with the project. And you have them again when specifying the dependencies, the build chain itself. Let's get actually rid of that. What you're going to do is you're going to let's replace the lines up here in the sequentials and parallels block, right? This doesn't work, however, because as mentioned before, this doesn't really register the build types with the project up here. So what you need to do is you need to ask the sequentials block, please give me all the build types. which you can do by simply calling .build types. And then you say build types for each, and then call the method build type again with the iterator. So for every build type, you register the build type with the project. That's it. So the for loop simply replaces those 4 specific lines up there. And then last but not least, what you want to do is you want to have a look at the last build type and then simply set a VCS trigger. That's all you want to do. So now you refactored your file a lot actually. Let's see if you commit the changes, if you commit and push the changes, what happens? If things are still working, okay. So the commit worked, everything got pushed. Let's go back to the build server. Actually, let's edit the project and go to the version settings tab again. Scroll down, force reloading the changes from the VCS, and let's see what happens. So now TeamCity is fetching the config from VCS. It's going to take a second to run the DSL. And after a couple of seconds, you're greeted with a couple of error messages. It seems that TeamCity couldn't apply the changes from the VCS from your code. And you get 3 error messages saying, well, there's a build type with ID ANU to-do list Maven. And there's 2 more build types with ID ANU to-do list _ Maven. Why is that? Now, when you go back, what happens by default with your Kotlin DSL, that every build type in TeamCity needs its unique ID. And in Kotlin DSL, the ID is generated by having the project ID, so ANU to-do list, _ with whatever the class of the build type is, so Maven in this case. And as I'm registering 4 build types here, I'm going to have 4 build types which are called ANU to-do list _ Maven, which clashes. And a simple fix is to simply specify an ID for every build type. And a quick workaround is to take whatever the name is that is being passed in, so fast test, build, slow test, package and whatnot, and call the method to external ID on it, which will sanitize the value, make sure it's a proper ID for TeamCity. And if you commit and push this change now, let's see, commit and push worked. Again, I'm doing a manual reload of the settings just to make things a bit quicker. Let's wait again for a couple of seconds. And now you can see the changes from the VCS were applied successfully. There's no more error messages. Now, when you scroll up and go to your project overview page, right, the build is running, everything worked as it pretty much did before. And let's open up the build chain again from the ANU to-do list. So you did all the refactorings of the settings KTS file. You'll still have your build chain as you did in the last episode, just with a lot less code. But there's also another side to it. So when you go back now, just let's think about what we did. We essentially created our new own class in here and still manually call the constructor of that class. And the generation of the build types happens inside that file. You could theoretically, and also practically, also have a file inside your TeamCity folder, a JSON file, for example, and create these build types by reading in the JSON file and then just building them on the fly. You cannot do network calls, so you cannot call external REST services, for example, to generate these build types because the Kotlin DSL runs in a sandbox and network calls at the moment are not allowed, though this might change in the future. But what I'm saying is that the more layers you build on top of the standard Kotlin DSL, the more difficult it gets for other employees to understand what's happening inside that file. And you have to make sure to find the right balance. However, you now know what you can do with the settings KTS file. You know all the basics of how to create build pipelines with your Kotlin code. And now it's time to talk about more advanced concepts like having context parameters or even unit testing your settings KTS file. So, see you next time.